Let's talk about GDP, Gross Domestic Product. This is the most important metric in this course for macroeconomics, and it represents everything we make, and buy. This is very important for the economy because it provides jobs in addition to things we need, and hopefully at prices we want. So GDP is things that are made on U.S. soil, and it doesn't include our factories overseas, mainly because they don't benefit our workers. They'll use foreign workers. So our GDP here on our domestic land includes our workers, and GDP is everything that we make, including goods and services. Remember the term CIGX. So this is for consumption, investment, government, and exports, minus imports. So let me go through each of them. Household consumption is probably about half of GDP, where it's goods and services people, families, households need, and that is, recorded what we buy. Business investment is things businesses buy. Don't think of it as investment, because just merely moving money around is not GDP. There needs to be actual production. So businesses buy buildings and factories and pencils and things like that. So think of it as business purchases. And this also includes inventory that's not sold. 3, government spending. This is everything the government buys. So the government may build bridges, buy bombs, and pay workers, that kind of thing. So that's included in GDP. And 4th is net exports. Now this includes 2 items. Exports, which is good because we make stuff, we get money coming in from other countries, and our workers benefit, but that gets reduced by our imports. Imports kind of reverse the process. Imports benefit other workers, foreign workers, and our money leaves the country. So net exports is exports minus imports. What's not included in GDP is used stuff, like used cars, which was counted originally when it was new, or underground economy, things that are maybe illegal, hard to count, that kind of thing. And also intermediate goods, such as maybe the battery or tires of a car that's made in a factory, because the whole car will be counted at the end. Some formulas related to GDP are, there's the first one, CIGX minus M, so that's consumers, like household goods, plus business spending, plus government spending, plus our exports minus imports, and that is our GDP, and that's counted over 1 year. Sometimes we will divide GDP by capita, meaning population, just to get a rough idea of what the wealth would be per person if it was shared equally. And that's just the GDP per year divided by the population. So our current GDP is $32 trillion a year, and our population is about 335 million. So that's about maybe $90,000 per person. Another formula, we know net exports, which I mentioned, is exports minus imports, and that equals net exports. A term called net national product is GDP for the year less depreciation. So depreciation means things are worn or used up or somehow reduced over the year. So that will be net national product. We won't use that very much in this class. there's a term called nominal GDP versus real GDP. Nominal GDP is the figure written down at the time GDP was counted, and those are just the numbers that are recorded. However, we may need to look at real GDP if we want to compare years, because inflation may distort those numbers. Let me talk a little bit more about nominal versus real GDP. So nominal GDP, is the amount of GDP recorded every year, and we can rank how well we're doing when we look at that. However, inflation may distort those numbers because our GDP is counted in dollars, and the value of the dollar may change. Some years it may take more dollars to buy the same thing. So we have to convert that to what's called real GDP. Real GDP has to be relative to a certain year. We fix a certain year as a base year, and we look at the relative difference between the two after controlling for inflation. So I'm going to show you how to calculate real GDP from nominal GDP. Let's make up some nominal GDP numbers for the year. So let's just say we have year 2000, and our GDP, nominal GDP, say is $100, or you can say 100 billion. And then in year 2001, say it's 105. And then in year 2002, it's 110. So it looks like those numbers are increasing, which is good. There needs to be growth in an economy so that investors will invest and see their money grow. However, we need to look at inflation. Are those just price increases? Because inflation may raise prices for no tangible reason, and that will be reflected here. So if there's a lot of inflation, our GDP may not have really grown. Tables like this will often come with a deflator number, a deflator index. So deflator index may look like this, and say the deflator is relative to the year 2000. These indexes are, close to 100, but we need to decimalize our index so that we can calculate with it. So what we're going to do is divide the deflator into nominal GDP to get the real GDP relative to a certain year. So we're going to hold a certain year, a base year, constant. So it's almost like we're looking at a lens. We're back in 2000, and we're looking back out to different years from that year. So when we're looking at the same year, our real GDP is the same. If we're having a base year of 2000 there, our dollar value is the same amount. Now we need to convert this nominal GDP into real GDP given a base year of 2000. So we're going to divide 105. We need to decimalize these so that we can divide into 105. And what is this number? Let's round it to $95. And let's convert this nominal GDP, 110, by dividing it by this number, 1.2. and rounded, that comes to $92. So what does this mean? When we control for inflation, our GDP looks like it actually went down. This was all price increases. But when we convert with the deflator, with a base year of 2000, we see that GDP has gone down. So we're holding this dollar value constant for 2000, and we're using it, those same dollar values, for the other years so that we can see the relative change to this year. And looks like quantity went down while price tags went up. Now, if the deflator is not given, you can calculate your own deflator. However, you need to have market basket data. This is market research data that has looked at prices of everything, and it looks to see what the price changes are every year for the same basket of goods. So this basket of goods represents everything, all goods and services. There might be a million things in there. And every year, the government keeps a consistent pricing of all these items and looks at the value every year and keeps track of that. So that is pure price increases, and we can create our deflator from that. Okay, let's look at the same years, same nominal GDP for each of those years, and let's create our own deflator so we can create real GDP figures. So we're going to hold 2000 as a base year. It's not important which base year we're working with. Just hold something consistent. And we're going to create a deflator by looking at the relative ratio of market baskets. So within the first year, say 2000, the deflator is neutral, or it's 100. And when we calculate, we're actually going to put a decimal in there. And then when we divide nominal by our deflator, this is going to be the same amount. In 2001, we need to look at the ratio of the new to the old. We're going to call it future value over present value. If this is future value and if this is present value, 55 over 50 is 1.1. Or in an index percentage format, 110. But when we calculate, we're going to put a decimal in there. We divide nominal by our deflator for that year, given a base year of 2000. And this is 95. Now we need to calculate another deflator for 2002, given a base year of 2000. We look at the ratios of our future target value over our base value, our present value, and that's 60 over 50, or 1.2. And in published terms, it's going to be 120, but we're going to put a decimal there so we can calculate that. We're going to divide this nominal GDP by 1.2, and that's going to be 92. I'm rounding things, and in financial or economic disciplines, it's acceptable to round maybe to the penny or the dollar. We're not going to be theoretically perfect in the math. Okay, so we have the same real GDP numbers. This is all relative to the year 2000. And if we picked a different base year, these numbers will be slightly different, but the relative change will be consistent. We'll still see how off or different the numbers are from nominal GDP. So to review what we did, we needed to make a deflator number based off of market basket values. And we look at ratios, and we're going to look at either, you can call it target or present value, future value over our base year present value. So we're looking at market baskets. We're going to put these on top of this number, 50, so that we get a ratio of this to this, this to the original, and also this to the original. And we come up with 1, 1.1, and 1.2. Or in published index values, it's going to be 100, 110, and 120. Let's review some GDP terms. Here's an example of some figures on GDP in 2020. So we have household consumer purchases of 14 trillion. That's the C. Remember CIGX. I is business investment, but think of those as purchases, 4 trillion. Government spending was 4 trillion. Exports was 2 trillion. But we have to subtract imports because it's a negative, and we get a total of 21 trillion GDP for that year. Now, what is the real GDP? Well, that doesn't make sense because we're not comparing it against other years, so there's no inflation component to this. We're just in a single year, and that's what it is. Now, to get net national product, we just subtract depreciation, which will be given to you because we can't just automatically figure that out. So that lowers GDP to 17 trillion because some of this went away through depreciation, it was used, that kind of thing. And to calculate GDP per capita, divide 21 trillion divided by our population, 330 million people.